Okay, so just a quick review on the factoring we've covered thus far, because we're going to add to it, and at the end of P4, they all get blended in together. So it's important to continually review what we've already had. So for today, for last week, we talked about factoring out the GCF. Nothing. And we talked about so I don't remember which question. You have something on the quiz. Could have been like a 27x to the third minus a 15x to the second. And so what's in common there? The 3 goes into both of them. And there's an x squared on the lowest exponent is what you want to take out on each. And then I would divide that 3 into the 27. I get 9. And one of the x's is left. Minus 3 goes into 15 5 times. And both the x's cancel out. So that would be factoring out greatest common factor. Then we did difference of 2 squares. And these both had to be perfect squares, and they had to have a minus between them. So something you could have seen like 49x squared minus 36y to the 4th. Those are both perfect squares. 49 is a perfect square, 36 is a perfect square, and even exponents on the variables make them perfect squares. So this would be 7x in the first spot, and then 6y squared in the second spot, and one would get a plus and one would get a minus. And then the one on the right is the difference, but those are not perfect squares. They both have to be perfect squares. Even if they were numerically perfect squares, the x to the first means it's not a perfect square. So that would have been where I stopped there. And then the third method was the perfect square trinomial. And this one had a perfect square at the front, a perfect square at the back. And the way we tested these out was square root the first term, I'd get 6x. Square root the last term, I'd get 5. And then double that product, so 30x times 2, and it's 60x. We ignore the sign when we do the test. We just make sure the value matches, and it did. So then we square root the first term, we square root the last term, we take the sign from the parentheses, the sign from the middle, put it in parentheses and square it. So those are the 3 that you should have learned by now. Hopefully we mastered those by now. And now we're going to add to it. And again, P4 at the end is going to put them all together. So like the last section is factor completely, which will literally fill them all. So this is part 2 or part B of your P4. And this is factoring perfect cubes and grouping. So we start with the perfect cube. A perfect cube would be both terms are values, whether they are numeric values or variables that would be raised to a cubed power. So you're looking for things like 27s and 64s and 125s. Those are going to be the values, right? You want to make sure we remember our 2 to the third, which is 8, our 3 to the third, which is 27, our 4 to the third, which is 64, 5 to the third, 125. Those are the most common you'll see. I'm not saying that those are the only ones that you'll see, but those are the most common ones that you'll see. And then anything that the exponent can be divisible by 3. So an x to the third is a perfect cube, an x to the 6th is a perfect cube, and x to the 9th is a perfect cube. Anything that can be divisible by 3. And the sign here matters. So if it's a plus, then there's 2 sets of parentheses. The first is u plus v. So we cube root the first term, we cube root the second term, and the first set of parentheses is that sum. Then it goes u squared minus uv plus v squared. For u to the third minus v to the third, we would do u minus v, u squared plus uv plus v squared. So that's the pattern. It's always the cube root and the cube root in the first one, then the square, then the product, then the square of the other one. And there's an acronym to help you remember the signs. It's SOAP. And it stands for same, opposite, always positive. So if you pay attention to the signs that are there, the first one matches the original. That's the same part. The second one is the opposite sign to the original. And the last one is positive. The same pattern happens with the next one. Same, opposite, positive. So that's what SOAP should help you with. So if I look at the example that's here, first of all, we want to identify x to the third would be a perfect cube and 125 is a perfect cube. So we start by cube rooting each of those. What's the cube root of x to the third? X, good. And what's the cube root of 125? 5. So the first set of parentheses is x, God bless you, and 5. We'll come back and fill in the signs. The second set of parentheses is that first term squared, so x squared. Then their product, which is 5x. Then the square of the second one, which is 25. And the signs are same as the original, opposite the original, and always positive. Now, if you FOIL that back out, you would get your question. So just like all the other types of factoring, these can be FOILed back out or distributed back out to get your question. Yeah.
What's the A in SOAP?
It's always positive. All right, so we go to the first one. Are they both perfect cubes? Yes. What's the cube root of x to the third? X. What's the cube root of 27? 3. So it's the first two, so x and 3. Again, we'll come back and fill in the sign. Then square the first one, multiply them together, and square the last one. Same, opposite, always positive. Go to 2. Are those both perfect cubes? Yep. What's the cube root of y to the third? Y. What's the cube root of 8? 2. So it's y and 2, y squared, 2y, and 4. Same, opposite, always positive.
So how do you figure out the middle number?
You just multiply them together. So instead of doubling the product like we do with a perfect square, you just multiply it. God bless you. All right, go to 3. Is 64 x to the third minus, are they both perfect cubes? Yep. So what's the cube root of 64 x to the third? 4x. Good. What's the cube root of 1? So the first set of parentheses is 4x and 1. Second set of parentheses is the square of 4x, which is 16x squared. Okay. And then the second set of parentheses, you square the first one, you multiply the originals together, so 4x times 1 would be 4x, and then you square the second one, and my signs, same, opposite, always positive. Questions on that one? Yeah.
How do you remember the last number?
The last one is the second number cubed. So 1 times 1 times 1. Sophia. Multiply the two together. So when you cube root it, you square the first one, you square the second one, and then you multiply them together to get the middle number. All right, go to 4. Are these perfect cubes? Is 3 a perfect cube? What times what times what gives you 3? It is not a perfect cube, okay? We don't even know about 192 already, but we know 3 is not. But is there something I can do to this before I get to the perfect cube test? Do they have something in common? Possibly. Do we think maybe 3 could go into both of them? Let's try it. So obviously it goes into here. Does it go into 192? You know the test for it does 3 out of your digits, right? 1 plus 9 is 10 plus 2 is 12, and 12 is divisible by 3, so that whole number is divisible by 3. Now we figure out what it is. So 3 goes into 19 6 times. That'd be 18. 3 goes into 12 4 times. So now I'm factoring out my greatest common factor. The 3 is going to go on the front, and then I'd get x to the third plus 64. And now what's inside those parentheses is a perfect cube. So I'm going to cube root the x to the third. I'm going to cube root the 64. The 3 still stays on the front. I can't lose it. First set of parentheses is the x and the 4. Second set of parentheses is the first term squared, the product of the 2, and the last term squared. And then it is same, opposite, always positive. All right, so 7 looks weird. You've got an expression in there, right? But is x plus 2 to the third a perfect cube? Yes. Is y to the third a perfect cube? Yes. So we cube root each. The cube root of x plus 2 to the third would just be x plus 2. The cube root of y to the third would be y. First set of parentheses would be x plus 2 and then y. We're going to fill in the sign in a minute. The second set of parentheses is going to be x plus 2 squared. Then the product of the 2, so y times x plus 2. And then the last term squared, y squared. And my signs are same, opposite, always positive. But this is not simplified yet. You have to expand and FOIL this. And a common mistake made on the quiz that has, or the test, that has to stop is taking this 2 and distributing it in. You cannot distribute with a sum or difference. You have to expand and FOIL this or use your shortcut. So I'm going to leave this first parentheses the same. The shortcut is square the first term, square the last term, double the product. So 2 times 2x, and it would be plus 4x. I have to distribute the y here, so I'd get plus xy plus 2y plus the y squared that's already there. If there were terms that could be combined, I would, but as it is, there are not. So I leave this big, messy, ugly thing because that's the answer. All right, second type we're going to talk about today, but we're on what, type 5 of factoring, is if you are factoring by grouping. This will happen when there are 4 terms. So if there are 4 terms, we group them, and you can't take anything out first because that's always when you always want to be, the first test is to see if you could factor something out. Once you test that out, then you group them together, and then you factor out the greatest common factor. So this is GCF, greatest common factor. And what's left is, then you take out the greatest common factor, and then what's left gets put together. So if you look at the example that's there, there's 4 terms. Usually 4 terms means factor by grouping. It doesn't always, because you can always sometimes just like take something out, right? But usually 4 terms means factor by grouping. So we actually group these in 2 sets of parentheses. Then I look at the first set of parentheses and I say, what's the greatest common factor? Good. So x squared is what I'm going to take out of that parentheses. So I'm going to divide this by x squared. I'm going to divide this by x squared. And I end up with just x and a minus 1. Then I repeat that process with the second set of parentheses. What can I take out of there? 2. So the 2 comes on the front. I divide this by 2 and this by 2, and I end up with x minus 1. Now what should happen after that step is this. You should see a repeated factor. Now the greatest common factor is x minus 1, and I take that out. I only need to take 1 out because it's just the greatest common factor. And then I would group together what's left outside the parentheses and put it in its own set of parentheses. And then again, if I had the extra time, I could FOIL that back out and check to see that it matches my original question. All right, so let's look at some examples. Go to 8. 4 terms. Does anything go into all 4 terms? No, so I'm going to group them. What can be taken out of the first set of parentheses? 2x squared. Good. 2x squared, and that means I'm going to divide this by 2x squared and this by 2x squared. So the 2 goes into 4 8 times, and if I subtract the 2 here, I'd get x to the third. Minus the 2 goes into 6 3 times, and the x squareds cancel out, so it's just 3. What goes into both 12x to the third and 9? 3. So I take out a 3. I'm dividing each of these by 3. And I end up with 4x to the third and minus 3. Now what's inside the parentheses is the same. So that becomes my first parentheses. And then what's left on the outside gets grouped together in the second parentheses. Okay, I'm checking to make sure nothing can come out again. They're not all divisible by one thing, so now I'm going to group them. This time, that negative is on the 5, so you have to make sure that when you're going to take it out, you treat that negative with the 5, okay? Up until now, it was a plus, so it didn't have an impact, but that negative is attached to the negative 5x, so be careful. On the first set of parentheses, what can you take out? X squared, and this becomes x plus 1. On the second set of parentheses, what can you take out? So if I take out a positive 5, I end up with negative x minus 1, right? Are the parentheses the same? How can I change that? Take out a negative 5. So instead of taking out a positive 5, I'm going to take out a negative 5, and then my parentheses are positive x and a positive 1. Now they're the same term, so the x plus 1 goes to the outside, and the x squared minus 5 is grouped together in the second set. So when that third term is negative, be careful, make sure you keep it with the number. All right, we'll do one more and then we'll save 11 for Monday. Again, look at all 4 terms. Nothing goes into all of them, so I'm going to group it. What can I take out of the first set? Good. And then I'd get x plus 5 out of the second set. Negative 5, and I get x plus 5. And I end up with x plus 5 and x squared minus 5. Now, if this 5 was a perfect square, I would have the difference of 2 squares there that could continue to factor. So that's how you'll see multiple factoring built into factor by grouping. Okay, so if that was like an x squared minus 4, now I'd get x plus 5 from the first parentheses and then x plus 2 and x minus 2 because it's the difference of 2 squares. Landon.
Can you speak about like the x plus 5, like with the 5x minus on the back, like negative 5x?
This one or this line?
Like
The second or the third?
the second.
So I took out an x squared here. So the 2x's canceled, there's only one left. And I took out an x squared here, so they're completely gone. And then on the second one, I took out a negative 5. So the negative 5 canceled, making it a positive x. And the negative 5 went into the negative 25, positive 5 times. So we'll leave 11 again for Tuesday. I'll say Monday, but Tuesday. Your homework will be on WebAssign. Okay, if you have issues, I definitely need to know about them before Monday evening at 10:30. Okay. I don't know that we're gonna